Children, I'm going to explain to you in this video how to calculate the relative atomic mass of an element, taking boron as an example. When you want to find the relative atomic mass of an element sample, you know elements contain different isotopes. Isotopes are different atoms of the same element having the same proton number, but different mass numbers. So when a sample of an element contains several isotopes, we need to find out total mass of individual isotopes, and we need to add them together. The total mass has to be calculated in that manner. And you divide that total mass of all the isotopes in a sample by the number of atoms taken into consideration. Now, in this question, you talk about boron. Boron is an element. Symbol is capital B. Boron has two isotopes. There are only two isotopes, boron 10 and boron 11. Sample of boron contains 18.7% of boron 10 and 81.3 of boron 11. So how do we calculate the relative atomic mass of this sample of boron? If you consider this field shown in circular manner, it's a sample of boron. I will consider that this is 100%. In this 100% area, if I think about the individual isotopes available, the smaller part shows you 18 point, it should be 18 point, not comma, 18.7% boron actually by mass. Boron 10 isotope is also shown as I have given in bracket, 10B. Now this is the boron 10 percentage in this sample. And then in the bigger portion, we have 81.3 boron 11. So two isotopes are there. These are the amounts of substances present in the system as a percentage. Now there are 18.7 atoms of B10. That is exactly what you see in the picture up there. There are 18.7 atoms of boron 10. Actually, you can't take 18.7 atoms, but when it comes to percentage values, we have to just assume if you take 100 particles, 18.7 atoms of them are of B10 type. And also, there are 81.3% of atoms of Br11. Now, how are we going to find out the total mass? Total mass of B10 atoms we can easily calculate in this manner. 18.7 is a number of atoms. Each atom has a mass 10. So the total mass of these boron 10 atoms is 187. Now you see the other one. There's another isotope. Total mass of B11 atoms is equal to, its percentage is 81.3. So we can multiply 81 by 3 by mass 11. It's something like one particle has the mass 11. Likewise, 81.3 particles have a total mass of 894.3. We can use a calculator and see. I've done this work for you earlier. Please take the calculator. You can please pause the video a little bit, take the calculator and check whether this answer comes. Now let me take some space on the right-hand side. Always it is better to draw a line to separate the next part of the calculation. So examiner finds it very easy to mark your paper. When you want to find out the relative atomic mass of a substance, this is what the formula looks like. We are going to use relative atomic mass. Given within bracket, shortened form is RAM in capital. This is equal to the total mass of the sample. Total mass of the sample divided by the total number of atoms. We have already found out total mass of the sample. No, actually, we have found out mass of individual isotopes. Remember, earlier we discussed, you can see at the bottom here on the left-hand side, boron 10, there are 18.7%. So total mass is 187 of one isotope type. The other isotope, boron 11, having 81 plus 81.3 as a percentage of abundance. The total mass of those elements, atoms, is 894.3. Now, to find out the total mass of this sample, we have to add these two together, 187 plus 894.3. We'll see the answer is going to be now. Please remember this formula, it's very important. Okay. Now the relative atomic mass is equal to, as I said, 187 plus 893 divided by 100. So answer is going to be 10.813. This has 3 decimal points. If the question asks you to write in 2 decimal points, then we can write the answer as 10.813. However, finally, when you do the work, please be in the habit of double underlining the final answer. I have given just one underlining. You have to make it double underline. So this calculation is summarized in this manner. You can go through this several times, do the work yourself, and learn how exactly we can work out the relative atomic mass of a given substance using the abundance values and the relative atomic mass values given to you. Please study this and practice. Thank you very much. That's the end of this small video.